So the first instruction for the conditional branch is BRGE. Okay, so this BRGE is actually a branch if greater or equal. But for this BRGE, okay, if you use a sign number, then you can use this BRGE. If not, if you use an unsigned number, then what you're going to do is you need to use the BRSH, okay, for branch if greater or equal. So this BRGE instruction tests the sign flags. Okay, so it will looking at the sign flags and branch relatively to the PC, okay, to the program counter or to the target location if S is cleared. Mean that, okay, every time you use this BRGE, the CPU will looking at the sign flags, and if the sign flag is 0, then the branch haven't happened. Okay, if the S flag is 1, then what happen here? The CPU will do the next instruction. So this is the syntax BRGEK. Okay, and then this K is the operands, means that D is the location that it can branches to. Okay, so for example here, okay, before we do any or before you use any conditional branch, you need to do some comparison. Okay, we need to execute a CP instruction. Why? Because every time you execute this CP instruction, what happen here is, okay, your status register, okay, the flags inside of this status register will be updated accordingly. Okay, so for examples here, okay, you're going to compare between two registers, so R11 and R12, and then after that, you're going to see whether these two registers, R11 is greater than R12. Okay, if R11 is greater or equal than R12, so what happened here is, okay, you will go or you will jump to this location, grade EQ. If not, okay, if R12 is greater than R11, so what happens? You will do the following instructions. Okay, so this is what the BRGE do. Okay, so this BRGE, again, the BRGE only used for the sign number. If you're going to check, okay, if you're going to compare between two registers that is an unsigned number, then you can use the BRSH. Okay, and then we look at this. The second instruction here is BRLT. Okay, so the BRLT is branch if less than. Okay, so this is also for the signed number. Okay, for the unsigned number, you can use BRLO. Okay, so the BRLT instruction tests the sign flag. Okay, again, it will check the sign flag, whether the sign flag is set or not. If the sign flag is set, then what happens? It will branch. Okay, the branch will happen. If not, then you need to do the next instruction. So for example here, okay, and first we need to compare between your two registers, because inside of these two registers you have two numbers. Okay, you're going to compare between register 11 and register 12. If register 11 is less than 12, so what happens is you will jump to this location. If if R11 is greater or equal R12, so what happens here is you will do the next instruction after the BRLT less instruction. Okay, so so this is the instruction that we always use okay, in the programming. Okay, then we have the BREQ. Okay, so this BREQ is common and frequently used in programming. Okay, because why? Because you're going to do some loopings. Okay, if you're going to make a loop, then you need to use the BREQ or BRNE. Okay, so the BREQ stands for branch if equal. So this instruction will test the zero flag. Okay, it will check the zero flag either the zero flag is set or not. Okay, for the BREQ, if the zero flag is set, means that your two numbers here is equal. Okay, so this is the syntax and this is the operand. Okay, so let's look at this example here. CP R11 R12. Okay, again you need to do this CP instruction. Okay, in order to update the flag inside of this status register. Okay, once you execute this CP instruction, then after that you can use the branch conditional. Okay, so in this case here we use the BREQ. Okay, so BREQ equals, so what happened here is if R11 is equal to 12, so now it will jump to this location, okay, to this label equal and do the NOP instruction. If R11 is not equal R12, so what happened? So you will do the following instruction. Okay, because this one here we going to see the Z flag. Okay, the Z flag will indicate lah either okay your result from this compare is 0 or not. If 0, okay, if the result is 0, so what happen? You know that which is your Z is 1, so you know that both number are same. Okay, if Z equal to 0, which is you know that from this compare instruction, you know that both number have different value. Okay, because the Z is 0. Okay, next we have the BRNE. Okay, so the BRNE stand for branch if not equal. Okay, you will branch if both number that you compare are not equal. Okay, so please change this one here, okay, to BRNE. So this BRNE instruction tests a zero flag. Again, it will test the zero flag and branch relatively to the PC if Z is clear. Okay, so every time Z equal to 0 and it will branches. Okay, if not, then the CPU will do the for next instruction. So this is the syntax BRNEK. So K is your label lah. Okay, which is it pointed to the location that you're going to jump or you're going to branch. For example here, okay, again, we have this, we need to use the CP in order to compare between two registers. Okay, if this R11 is not equal to R12, so what happens? You will jump to this location. Okay, you will jump to this label, not equal, and do the NOP instruction. If R11 is equal to R12, okay, what happens when Z is 1? So when Z is 1, means that the number is equal. So what happens? You will do the next instruction. Okay, so any question up until here? Okay, there is some of the, what we call here, the branch conditional. Okay, so other than that, okay, you can refer to this table here and you can see the branch taken if by looking at this condition. Okay, for the BRLT, for the BRSH and BRLO, okay, we will looking at this carry flags, either is 0 or the C equal to 1. Okay, so let's look at the exercise here. Okay, so you're going to determine if the highlighted branch will be taken or not. Okay, the first one here. Okay, so let's look at the first one. Okay, so first LDI R16 7E. So what happened? R16 equal to 7E. And then after that, LDI R17 11. So you have R17 equal to 11. And then SBRC R16 3. Okay, so what the SBRC do? Okay, what the SBRC stand for? Anyone? SBRC. What the SBRC do? Okay, you can open your
Subtract register with carry.
Okay, skip. Okay, so let's look at the SBRC. What the SBRC do? Okay, we already learned about this one here. So SBRC is a skip bit if the registered clear. Okay, SBRC. Okay, skip if bit in a registered is clear. Okay, so this is the syntax SBRC RR followed by B. Okay, which is B is the location of your bit. Okay, so let's look at this one here, the exercise. All right, where is this? Okay, here. Okay, so SBRC R16 3. Okay, so now you're going to look at the R16. So this is your R16. Okay, what is the value of R16? So in this case here, okay, you're going to change this R16 to binary representation. Okay, so it will be 0, 1, 1, 1 for 7, while E is 1, 1, 1, 0. And then you're going to look at bit 3. Okay, so 0, 1, 2, 3. So this is your bit 3. Okay, so since this bit 3 is 1, so what happened? Is it the for this BRPL is the next instruction is skip or not? What happened here after you execute the SBRC R16 3? Okay, means that okay, you need to okay, since the condition is false, okay, so means you need to do the following instruction. Okay, you cannot skip the BRPL semula. Okay, you need to do the BRPL semula and then after that you do the following instruction. So for the first one here is the if the highlighted branch will be taken or not. Based on this answers, is it the branch taken or not? Okay, so this one is not taken.
Doctor, can you repeat again? Like how the SBRC is it 3?
Okay, so the SBRC stand for skip if bit in register is cleared. Okay, so now you have this what we call here instruction SBRC R16 3. So you need to see the bit at location 3, okay, the bit 3 inside of your R16 whether it is a clear or not. Okay, if it is clear, what happened here is okay, if the if the bit 3 equal to 0, so what you're going to do, you need to skip the next instruction. If bit 3 inside of your what we call here R16 is 1, so you need to do the next instruction. Okay. Okay, so now we're referring to the R16. So this is your R16, and then you have the value inside R16 is 7E. So you change it to the binary number. Okay, binary representation. So 7E is actually is 0, 1, 1, 1 for 7, while E is 1, 1, 1, 0. Okay, so now you go to bit 3 and you found out, okay, this bit 3 is 1. So what happened when bit 3 is 1? Okay, means that you cannot skip this BRPL semula. Okay, this instruction you cannot skip. Why? Because the bit 3 is 1. So what happened here? The branch not taken. So for in this case, for the question 1, okay, the highlighted branch is not taken. Okay, what about number 2? Okay, so we do line by line, LDI R16 7E. Okay, so again, you have a R16 equal to 7E. And then after that, out DDRA R16. Okay, so you send out this 7E to DDRA. So automatically DDRA will have the same value, 7E. And then SBIC. So what the What is SBIC?
It's the same as the SBRC, but it checks the input output register instead.
Okay, so let's look at the SBIC. Do we have the SBIC? SBRS. Okay, this one not. Okay, I need to refer to. Okay, so we have the instruction set. Okay, from this instruction set, you find the SBIC. All right, so this is your SBIC. Okay, so what this SBIC do? Okay, skip if bit in IO register. Okay, now we'll go looking at the IO register. Previously, we looking for this SBRC. We're looking at the general purpose register. Now we're going to look at the bit in IO register. Either it is clear or not. So it actually is similar lah. Only that SBRC, we're looking at our general purpose register, but SBIC, we're looking at the IO register. Okay, so now, where is it? Okay. So SBIC DDRA5. So now you're going to see bit number 5. Is it clear or not? Okay, so again, okay, you change this value here. Okay, 7E to binary number. So you will get 0, 1, 1, and then 1, 1, 1, 0. And then you identify bit 5 for 5. And since this bit 5 is 1, so what happened? Okay, you will not skip the JMP semula. Means that you need to execute the following instruction. So in this question here, branch is not taken as well. Okay, what about number 3? Okay, so LDI 7E put to R16 again. Okay, R16 got 7E, and then LDI R17 11. So R17 will have 11. ADD R16 R17. So ADD. Okay, so what happened here? R16 equal to R16 plus R17. So you need to add these two numbers here. Okay, then you found out R16 plus with R17, which is 7A plus 1, 1, you will get okay, you get 8F. Okay, so now BRNE. So what the BRNE do? Okay, so let's look at the BRNE. Okay, so this BRNE will looking at Z flags. Okay, it will check the Z flag, either the Z flag is 0 or not. If the Z flag is 0, so what happens? The branch will taken. If not, then you need to do you need to execute the next instruction. Okay, so according to this instruction here, after you did the execute the ADD R16 and R17, what happened to your Z flag? Is it your Z flag equal to 1 or 0?
0.
Okay, 0. Why 0? Because okay, after you do the addition, okay, you have the value. Okay, is after you have the value here. So what happened? Z automatically equal to 0. And what happened to BRN semula? Then you will branch. So for this one here, okay, the branch will taken. Okay, so this is for the conditional branch. Any question up until here for the conditional branch? Okay, for the conditional branch, every time you're going to branch, you need to see the condition. If the condition is met, then the branch will happen. If not, then you need to do the following instruction. Okay, if no question, then we're going to move to the structure programming. Okay, so the structure programming aims on improving the clarity, quality, and development time of programming by making extensive use of subroutine, block structure, for, and a while loop. Okay, so there are 5 basic structure programming. Okay, the first one here is if then, and then we have the if then else, while loop, do while loop, and for loop. Okay, so in the next slide, you will learn how to do a structured programming by using assembly language. So how to do that? So to do that, okay, we can use the BRCC. Okay, you can use the branch conditional, okay, to emulate the structured programming techniques that are present in the C language. Okay, so in this assembly, we will using this branch condition. Okay, so this is the pseudocode. Okay, this is the structured programming. Okay, you can divide them to the pseudocode and the assembly language. So this is how you write in the pseudocode, and this is how you write in the assembly language. Okay, so first let's look at the if then. Okay, so this if then is probably the simplest of structure programming. Okay, for example here. Okay, so let's look at this one. Okay, if n equal to 1, then what happen? M equal to 0. Okay, for every structure programming, I advise you to draw the flowchart. Okay, so that you can see clearly what happened and what instruction that you're going to use. Okay, for each of the condition. Okay, so this one here, okay, you're going to check. Okay, is n equal to 1? If yes, what happened? If no, what will happen? Okay, so if yes, okay, according to this one, this line, yeah, okay, if yes, then m equal to 3. Okay, so this is your start lah. Okay, starting. Okay, then you have a condition. Okay, so this is the symbol for the condition. Okay, is it n equal to 1? If yes, then what happen? You put m equal to 3. If no, what happen? Okay, then you exit the loop. Okay, the condition. Okay, so for this structured programming, okay, the way you choose, either you're going to pick a yes or no, will determine what instruction that you're going to use. Okay, so in this case here, okay, so now we are going to do a comparison between n is it equal to 1. Okay, so the instruction that you can choose is either B, R, and E. Okay, branch not equal or branch equal. Okay, so now here, okay, so now if you choose the BREQ, so this is where you need to put the BREQ instruction. Okay, which is if the n equal to 1, so yes, then m equal to 3. If you choose no, then the instruction that you're going to use is BR and E. So we have 2 solutions here. One by using the BR and E, and the second one by using the BREQ. Okay, so we have 2 numbers, which is n, m, n. Okay, so you have 2 numbers here, which is n, m, n. You are going to compare your n, m, n. So let's n, okay, I represent by R16, while m is represented by R17. Okay, so you have 2 solutions. Okay, so I just divided them here. Okay, so the first solution, I'm going to use this one here. Okay, so this one here by using the BR and E. Okay, so what I'm going to do is here is, okay, first we compare. Okay, we can use the CPI. Okay, compare with immediate. Okay, N is R16. What number that you're going to compare? 1. Okay, so CPI R16 1. And after that, okay, by using the BR and E, what happens when P not equal? So when not equal, it will go to N. So I put a label tamat here. Okay, so now this is my label tamat, which is my N. And what happens when ends? So I just put the no operation. Okay, means that do nothing. Okay, so compare R16 with 1. If R16 not equal to 1, so what happens? I will jump to this location. Okay, if R16 equal to 1, so what happens? So I need to make sure that M equal to 3. So M is R17. So how to make the R17 equal to 3? So I just put LDI R73 with 3. Okay, so this one here, okay, I just simply write, okay, this is N, sorry, is it N equal to 1? Okay, so this is the comment here. Okay, if yes, go to tamat. Yes, sorry. If not, go to tamat. If yes, what happened? Okay, then you set M equal to 3. Okay, and then here you see here, after you load R17 with 3, what happened? Okay, then you need to go to the ends lah. Okay, so just okay, so next instruction should be this instruction as well. Okay, so you have 4 lines of instruction. Okay, this one by using the BR and E. What happens if I use the BREQ? Okay, so this is the second solution by using the BREQ. Okay, first, what I'm going to do, again, we compare N with 1. Okay, so CPI R16 with 1. Okay, and then use the BREQ. Okay, what happens if the N equal to 1? Okay, so when N equal to 1, so I need to jump so that M equal to 3. Okay, so now go to equal. Okay, so I put my equal label down here. Okay, so under the equal, so what happened? When the N equal to 1, so M equal to 3. So I need to load my M is R17 with 3. Okay, then after that, after I load M with 3, what happened? So I need to go to N, which is NOP. Okay, so this is when equal. Okay, when yes. What happened when no? Okay, when no, okay, so I need to do jump tamat. Where is my tamat? Okay, I need to put here lah. Okay, so this is my tamat. So this is my second solution, and this is first solution. Okay, you see here, by using the first solution, by using the BR and E, you just need 4 lines of instruction. But by using the BREQ, you need 5 lines of instruction. Okay, any question up until here? This is for the if-then statement. Okay, if no question, then we go to the if-then else. So the if-then else construct has an alternative statement that is executed when the condition is false. Okay, previously, when the condition is false, what happened? Okay, we just go to the end. Okay, exit from the loop. But now, if the condition is false, so what happened? You have a statement inside there. Okay, so both true and false, you have a statement. Okay, the code that you're going to do. Okay, if the condition is either is a false or true. Okay, for example here, okay, we have the same programming. Okay, which is you're going to compare, is it n equal to 1? Okay, if yes, no. Okay, if yes, what happen? You set m equal to 3. Okay, if no, then you set your m equal to 2. Okay, after that, you exit from the loop. Okay, you go end. So this is your start. Okay, so again, for this one here, okay, we can use either you're going to use the BRNE or BREQ. So this is a BRNE. If not equal, so we can use the BRE. And if equal, we can choose the BREQ. Okay, so again, you have two solution. Okay, so let's look at the first one here by using the BRNE. Okay, first, what we're going to do? Okay, compare. Okay, let's use the same thing. Okay, n is equal represented by R16 while m is R17. Okay, so first I'm going to compare my R16, is it equal to 1 or not? Okay, so CPI by using the CPI R16 1. So compare R16 with 1. Okay, then after that BRNE. So what happened when when not equal? So I will jump to not equal label. Okay, so tak sama. Okay, I just put the name tak sama, which is a not equal. Okay, and then the tak sama I put down here. Okay, what happened when the tak sama, which is not equal? Okay, when not equal, I need to load my R17 with 2. So LDI R17 with 2. And after that, what happened? Okay, no operation. Okay, do nothing, which is exit from the loop. Okay, and next, what happened if the condition is false? Okay, so when the condition is false, what happened here is I need to make sure that m equal to 3. So when the condition is false, so LDI, okay, and then R17 with 3. Okay, and then after that, after I load the R17 with 3, what happens? Then I need to go to n, which is tamat here. So put jump, which is, okay, you can jump unconditioned to the NOP. So this is a tamat. So I just put label tamat at my NOP. Okay, so this is the first solution. Or sometimes, okay, instead of using the NOP, sometimes you will see some of the programmer will change this one here. Instead of NOP, then it will come JMP tamat. Means that it will keep looping at this location. Okay, jump tamat. Where is your tamat? Here. So it will keep looping here until you exit from the program. Okay, so this is the first solution. And let's look at the second solution by using the BREQ. Okay, again, we compare your n, which is R16 with 1. And then after that, BREQ. Okay, when BRQ yes, okay, which is summer. Okay, when the n equal to yes, which is equal. So I just use the word summer here. So what happens when equal? So we will jump to here. So this is my summer. Okay, and then what happens? Okay, I need to load m with 3. So LDI R17 with 3. And After that, we exit from the loop. Okay, so we can use the jump tamat, and this is my tamat. Okay, and this is when the condition is true lah. Okay, what happens when the condition is false? So when the condition is false now, what happened? I need to make sure that m equal to 2. So LDI R17 with 2. And after that, I jump to the end. So jump tamat. So automatically it will go to here. Okay, that's why I need to put the jump tamat. Okay, if I not force the CPU to go to this tamat, what happens is the CPU will simply do the following instruction, which is LDI R73. This is not true lah, according to this program here. Okay, so that's why you need to make sure that it will go to this location. Okay, so you can use the branch unconditional. Okay, unconditional branch. Okay, so this is for the if then else. Any question up until here? Okay, then we have the while loops. Okay, so while isn't a whole lot more difficult than if. Okay, so this while loop here, okay, if you can see here, okay, you have a condition, and then what happened? A part of that, okay, and then you need to increment your n. Okay, you need to do some increment. If the condition is not met, then after that it will exit from the while loop. So how to do that? Okay, again, we draw the flowchart, okay, so that we can identify what instruction that we're going to use. Okay, so this is your start. And then you have a condition here. Okay, so now the condition is it at m greater or equal than n? Okay, so if yes, if no. Okay, so yes and no. Okay, so if yes, what happened? Okay, so yes, you need to increment your n. So n plus plus. Okay, and then what happened? It will start back and check the condition. If no, then it will go to n, exit from this while loop. Okay, so for this case here, what type of instruction that we going to use? Can anyone help me? What instruction that we're going to use here? Is it BREQ and BRNE or any other instruction? Siapa nak tolong?
BREQ, Doctor.
BREQ.
EQ.
Okay, one of you thinks that BREQ. Other than that? Okay, so
I think we can use BRNE as well.
pardon?
I think we can use BRNE as well.
Okay, yes. Okay, you saying that we can use the BRNE and BREQ. Okay, so let's look back at this condition here. You see the condition is m is greater or equal than n. So you cannot use the BRNE or BREQ because you're going to check whether your m is greater or equal or is less than n. Okay, that is the condition that we're going to use. Okay, so in this while loop, okay, you can choose either BRLO, okay, because this is an unsigned number. So we just assume that all the condition here is unsigned number. So that's why we use the BRLO. If the condition is a signed number, then you can use the BRLT. And for this one, you can choose the BRSH. Okay, so let's look at this one here. What the BRSH and BRLO do. Okay, so BRSH is, sorry, where is this? Okay, here, BRSH, okay, branch if same or higher, and BRLO stand for branch if lower. Okay, so you're going to use that instruction. Okay, now what we're going to do? Okay, again we assign our register. Okay, which is M equal to R17, while N is R16. Okay, you start your program, and then what happen here? You're going to compare. Okay, so this one here, okay, we need to compare. So now you need to compare between two registers. Okay, what instruction that you're going to use? We're going to use the CP instruction. Okay, why CP instruction? Because you're going to compare M with N. Previously, we compare N with a constant number. So that's why we use the CPI. So now we are going to compare M and N between two numbers. So we use the CP instruction. So CP R17 with R16. Okay, so I compare M with N. Okay, then I use the BRLO. Okay, so the first one is BRLO. So what happens when BRLO? So if M less than N, what happens? Then we'll go to tamat lah. Okay, so it will go to tamat. Okay, where is my tamat? So I just put down here. Okay, so this is my tamat label, and then jump tamat. Okay, so it will keep looping here. Okay, so this is when the condition is true lah. What happens when the condition of BRLO is false? So what happens when false is, then I need to increase my N. Okay, which is N plus plus is actually equal to N plus 1. So what instruction that I'm going to use here to represent N plus plus? Anyone?
Increment.
Okay, increment. So we can use the INC. So INC actually is a, okay, INC R16 because we're going to increment N. So R16. So actually INC is stand for increment by 1. Okay, increment the register by 1. Okay, then what happened? After I increment, when okay, I already did the increment of the N. Next, what I'm going to do? Okay,
Use jump
okay.
extraction.
Okay, we need to check the condition again. Okay, by using the jump instruction. Okay, so jump ulang. Okay, I just put the ulang, or the ulang is actually stand for repeat. Okay, so where I need to put my ulang, so I put here, which is you need to compare again R17 with R16. Okay, so this while loop will keep looping until, okay, until your N greater than M. If not, it will keep looping. Okay, so this is by using the BRLO. So what happens when we choose the BRSH? Okay, similar lah. Okay, it's quite similar. Okay, so this is the second solution. Yeah. Okay, again. Okay, I compare CP R17 with R16. Okay, after I compare, I use the BRSH. Okay, so BRSH, so this one I call it as a greater. Okay, where is my greater? So I just put here. So what happens when greater? N plus plus. Okay, so increment R16. And then after I increment R16, so I need to check again the condition. Is it M greater than N? Okay, so just put the jump here, JMP, and then ulang. So this is where my ulang label. Okay, the label for ulang I just put here because I'm going to compare again. Okay, so what happens when the m smaller than n? So when m smaller than n, so what happened here? So we just ended the program or exit from the while loop. So in this case here, we can use the jump tamat and put the tamat is here. Okay, this is for the while loop. Any question? Okay, then we have a do while loop. Okay, so the do while loop is a looping structure that doesn't compute the test before entering the loop. Okay, it's run the loop once and then compute the test. Okay, it is quite different with the while loop because okay, you will run the statement first, and then after that you check the condition. Okay, if for the while loop, okay, you need to check the condition, and then after that, if the condition is met, then you run the statement. But this one here, you run the statement one time, check the condition. If the condition is true, then you do the same statement. If not, then you exit from that loop. Okay, so this is okay. So let's look at the what we call here through the flowchart. Okay, sorry. So the flowchart is something like this. Okay, you have the start. Okay, so this is your start, and then okay, you see here n plus plus. Okay, you do the n plus plus. After that, you check the condition whether it's correct or not. Okay, is it that m equal or greater than n? If yes, what happened? If no, what happened? Okay, if yes, what happened if yes? Then you will increase the n plus plus again and check the condition. If no, then you exit from the loop. So this is the flowchart for the do while loop. Okay, so again for this one here, okay, you can choose either BRLT, okay, or BRSH. Okay, so this one here, BRSH. Okay, so how to write the what we call here the program? Okay, first and second. Okay, so you will have two solutions. Okay, the first one is by using the BRLT. Okay, so we're looking at the BRLT. So this is the first one. Why I cannot change the color? Okay, never mind. All right, so first I need to increment my R16. Okay, so again, R16 is N and R17 is M. So increment R16. Okay, this is the first instruction. And then after that, compare M with N. So R17 with R16, we're going to compare the M with N. Okay, and then use the BRLT. Okay, so what happens when M smaller than N? So when the smaller, then we go to tamat. Okay, which is we exit from the loop. Okay, so where is my tamat? So I just put the tamat here, and this is my jump tamat. Okay, what happens when the M is greater than M? Okay, so when the M is greater than M, so next I need to increase my R16. Okay, so increase R16 and then, or you can simply, instead of increase the R16, okay, you can jump to here. Okay, because we already increased the R16 at the top of the programming. Okay, why not? Instead of we put this one here, okay, jump ulang. Okay, so this is my ulang. So increment R60 again, compare R17 with R16, check again whether it's a smaller or greater. If it is M is greater, then we keep repeating. If M is smaller than N, that is you go to tamat. So this is the first solution. What about the second solution? By using the BRSH, okay, again we need to increment R16. Okay, this is the first step, and then compare CP R17 with R16. Okay, once you finish the compare, so what happened? Okay, by using the BRSH. Okay, when yes, then you need to increment again your R16. So we just put the ulang there. So where is my ulang? So I need to put here at this location. So this is my ulang. So what happened when your N is greater than M? So then after that, what happened? We just go to the N. Okay, so tamat. So this is a jump. Tamat. And this is my tamat. All right, so this is for the do while loop. Okay, next we have the for structure. Okay, so this for structure is a common loop that you are going to use. Okay, the for structure is a common one. Okay, the common structure programming that you always use in your programming. Okay, so this is the for structure in the C programming, and this is the for structure, how to make a for structure by using the assembly language. So again, okay, what you're going to do here is you need to draw your flowchart so that you know what instruction that you're going to use. Okay, and you can simply write your program according to that flowchart. Okay, first we need to initialize n equal to 0. Okay, so this is your starting. Okay, then you need to initialize n with 0. So this is the first. And then after that, initialize m equal to 1. Okay, so you need to initialize these two first. And then after that, after you initialize n 0 and m equal to 1, then, okay, you're going to see whether m is smaller than 10 or not. Okay, so we check the condition. Is it m smaller than 10? If yes, what happened? If no, what happened? Okay, so if yes, okay, it says that n plus equal to n. What happened here? What is n plus equal to n? So this is actually n. Okay, before we do the n plus equal to, okay, correct. Okay, so n plus equal to m. So what happened here? So you're going to n equal to n plus m. And then after that, okay, you're going to increase your m. Okay, so m plus. This is what happened when the condition is true. And then after that, okay, you're going to check back lah. Okay, is it a m smaller than 10 or not? If no, okay, if the m is greater than 10 or equal than 10, so what happened? Then you need to go to n. Okay, you're going to tamat. Okay, so now we're going to identify lah what instruction that we're going to use. Okay, so again, because this is a comparison between two numbers, which is, okay, you see here, this is m less than 10. So why not we use the BRSH for this one and BRLT for this one. Not BRLT, sorry, BRLO. Okay, because this is an unsigned number. Okay, so BRLO and BRSH. Okay, so we have two solutions lah. Okay, again, we have two solutions. So I just put the, okay, for this one here, the first solution. Okay, so what you're going to do here is, okay, first, make sure that n equal to 0. How to make the n equal to 0? Okay, you can simply use the CLR instruction, clear R16. Okay, so R16 actually your N, and R17 is your M. Okay, so clear R16, and then after that, load your M with 1. So LDI R17 with 1. So now M equal to 1. After that, what you're going to do? You're going to compare. Okay, so CPI. Why CPI? Because this is constant number. Okay, you're going to compare with 10. Okay, why not we just use the CPI? So CPI, what register now? M, which is R17 with what number? 10. Okay, and then after that, by using the BRSH, okay, what happens when BRSH? Okay, then you go to N. Okay, so tamat. You jump to tamat. So this is your tamat. And then you can put the jump, and this is your tamat. Okay, what happens when the condition is false? Okay, which is the M smaller than 10. So you need to do this thing here. Okay, which is N equal to N plus M. So what instruction that you're going to use here? N equal to N plus M. Okay, this one you can use the ADD instruction. What about this one? M plus plus, this one you can use the INC instruction. So ADD. Okay, make sure that what we call here, the register that you're going to use is correct lah. Okay, make sure that it is started with R16 because N plus with your M, and then put the result to your N, which is R16. Okay, and then after that, increment your R17. After you increment your R17, so what you're going to do? Okay, you're going to check back. Okay, you're going to do this line here. Okay, so why not we just use the JMP jump? Okay, and then ulang. Okay, where am I going to put my ulang label? So here. Okay, and it will keep repeating until, okay, M equal 10 or M greater than 10. Okay, what about if you choose to use the BRLO? Sama juga lah. Okay, same thing. CLR R16, LDI R17 with 1, and then compare R17 with 10, and then just use the BRLO. Okay, what happened when BRLO? So means you just put any labels lah. Okay, so labels here I just put smaller. Okay, and then what happened when smaller? Okay, so just put here smaller, and then what happened when smaller? So I need to add. Okay, use the ADD R16 R17, increment R17, and after I increment R17, then I need to check back my condition. Okay, so jump ulang. So where is my ulang? So I need to put here. Okay, what happens when the condition is what we call here false? Okay, when the condition is false, then we just simply end our program. So you can put the JMP. Okay, sorry, not here. Okay, JMP tamat, and this is my tamat. Okay, any question up until here? We already learned about the structured programming and how to write a structured programming by using assembly language. Okay, if no question, okay, then we go to the next slide, okay, which is a conditional branch loop. Okay, we're going to see how to do loopings. Okay, you're going to create a loops. Okay, so loops is actually a repeating a sequence of instruction or an operation a certain number of time. Okay, if you're going to to repeat the sequence more than once, then it is advised to use loops. Okay, so in AVR, there are several ways to repeat an operation many times. Okay, the first way here, which is you repeat the operation over and over, means that you just simply cut and paste the same instruction over and over. But by using this technique here or this method here, you will wasting your program memory. Okay, so for example here, okay, you're going to add 3 to R16 6 times. Okay, so first we clear R16. Okay, so clear R16, and then because you're going to add R16 6 times, okay, which is R16 equal to R16 plus with 3. How many times? 3 times. So we can use the ADD instruction. So, but you need to make sure lah. This 3 here, you need to put it to your GPR. So in this case, we put to R17. Why? Because the ADD instruction only evolve between 2 registers, okay, which is RD and RN. Okay, so that's why LDI R17 with 3. Sorry, not 3 times, 6 times. Okay, so then ADD R16 R17. So this is the first one, and then you copy paste again, second, third, fourth, fifth, and sixth. Okay, what happens if you're going to do the same thing? Okay, but now you're going to repeat it 100 times, 200 times. So what are you going to do? Do you want going to copy paste the same instruction over and over? Okay, so that is that become too much code space needed, which is you going to waste your program space, and at the same time it will consume a lot of your time. Okay, to cut and paste for 200 times. Okay, so to do that, okay, to overcome this this issue, so we can choose the second method, which is by using a loop. Okay, for using a loop, okay, always the thing that the instruction that we can use is by using the BRNE instruction. Okay, so BRNE instruction is the common instruction in order to create a loop. Okay, so how to do the BRNE, how to make a loop? Okay, so this is the two, what we call here, the two instructions that you're going to use in order to create a loop. Okay, which is first you decrement your counter register. Once your counter register is decrement, then you're going to check whether is it equal to 0. If the counter register is not equal to 0, then what happens? You go back and keep doing the same thing over and over until your counter register equal to 0. And when the counter register equal to 0, then you exit the loop. Okay, so let's look at the examples here. Okay, you are going to write a program, okay, to clear R20, then add 3 to your R20 10 times, and after that, send the sum to the port B, use the 0 flag, and BRNE. Okay, first you're going to clear your R20 and add your R20 with 3 10 times, and after that, the result of the addition, okay, you're going to send it to your port B. Okay, so how to write this program here? Okay, to write this program, because this one here, okay, you're going to use the port B, okay, the IO register. So every time you're going to use the IO register, okay, make sure that you include this file. Okay, so include m32def.inc. Why we need to include this file? Okay, you can refer to the module 5. Module 4. Okay, you can refer to module 4. I already asked you to watch the video earlier. Okay, on this directive assembly. So this one we call it as a directive assembly. Okay, you can refer to module 4 why we need going to include this 5 here. Okay, then once you include this 5, and then what you're going to do is, okay, we need to make sure lah, okay, because in this example here, okay, you're going to add 3 with R20 10 times. So what you're going to do is you need to have one counter register. Okay, so the counter register is R16. Okay, so LDI R16. So how many times? 10 times. Okay, so this is your counter. Okay, so this counter is used in your loops. Okay, as your counter loops. Okay, and then clear your R20. Okay, you can simply clear your R20 by using the CLR R20. Okay, so automatically R20 equal to 0. Or you can simply, or if you don't want to use the CLR, you can simply use the LDI R20 0. Okay, so this is the same thing, which is you're going to clear your R20 with 0. Okay, next, okay, you're going to add this R20 with 3. Okay, how to add R20 with 3? By using the ADD instruction. But for the ADD instruction, it must involve 2 registers, which is RD and RN. Okay, cannot use the immediate numbers. So how to do that? Okay, so you need to make sure these 3 here, number 3, you put to another register. Okay, so load I R21, for example, with 3. Okay, then after that, you add these numbers here. Okay, so ADD R20 with R21. Okay, after you add this number, this is for the first time you do the addition. But in this question here, okay, you're going to add this number how many times? 10 times. Okay, 10 times. So what are you going to do? Okay, you need to create a loop. Okay, how to create a loop? Okay, by insert these 2 instruction here. Okay, so decrement your Rn. What is our Rn? Our counter register. So decrement R16. So now R16 become 9. And then use the BRNE. Since R16 not equal to 0, so what happen? It will keep looping. Okay, so we put ulang. Okay, where I going to put the label ulang? So I put here. Okay, why? Because after I decrement R16, then we add again R20 with 3. Decrement R16, if R16 not equal to 0, and it will keep repeating until 10 times. Okay, once we add the same number 10 times, so what happens? After that, okay, you're going to send the result to your port B. So how to send the result to port B? Okay, to do that, first is this is a port B, port B. Okay, now you're going to send a number. Okay, send to port B. Okay, so what you're going to do to your port B? Okay, you need to initialize your port B. Either you're going to initialize it as an input port or output port. So in this case, what we're going to do to port B, is it we're going to make it as an input or output port? What say you? Okay, you have the number. Okay, you have the result, which is in R20. Now the result, you're going to send it to port B. So now you're going to set, is it your port B become a input port or your output port? Which one you think is the correct one? Okay, so go saying that output port. Yes, we need to initialize the port B as a output port. So how to make the port B as an output port? Okay, by writing to your DDRB. Okay, what value that we need to write to DDRB? Is it 1 or 0? 0 or 1? Output.
Output
One.
1.
Okay, output is 1. If you put 0, then it becomes input port. Okay, so what happened here? Okay, we initialize port B so that port B become output port. So how to initialize? So LDI R17 with OXFF. Okay, why FF? Because we're going to put 1 to DDRB. So send out DDRB R17. Okay, so what happened here now? Port B become output port. Okay, once your port B become output port, then after that you can send the result to your port B by using the out instruction. So out port B with result from R20. Okay, so you send the sum to your port B. Okay. So this is how you're going to create the loop. Okay, so make sure that this two line is very important lah, in order to create a loops. And another one is this register here. Okay, we call it as a counter register. Okay, to create a loop, you need to have the counter register, and after that, you need to have these two line here in order to check whether your counter register is equal to 0 or not. If not, then you need to keep doing the loops lah until the counter register reach 0. Okay, so this is the explanation behind the what we call here, behind this instruction here. Okay, so first we set the counter with 10, and after that, okay, you clear your R20 with 0, and then put 3 to R21. Okay, and then you add your R20 with R21, means that this is R20 equal to R20 plus with 3. And then you decrement your counter. Okay, and then if the counter is not yet 0, then it will keep repeating, do the addition until your R16, your counter is equal to 0. Okay, and if 0, what happens? You place the result to your port B. Okay, so this is the instruction. Okay, any question up until there is a loop. Now we're going to see the loop inside a loop, or called as a nested loop. Okay, why we need to have the nested loop? Okay, so the maximum number of repetition in one loop is 255 times, which is FF, because your register, your GPR, your counter register is 8-bit size. Okay, it's a 8-bit. Okay, so the maximum number is FF or 255. So what happened if you're going to create a loop more than 255, which is, for example, you're going to create a loop of 500 times. So how to do that? Okay, to do that, okay, we need to use the nested loop. Okay, so to repeat an action more than 255 times, we need to use a loop inside a loop, which is your nested loop. So in nested loop, we use two registers to hold the count. Okay, for example, this one here, 500. Okay, you need to have two counter register. Okay, one that have the 10, and the second one will have counter 50, which is when you multiply 10 with 500, you will get 500 times. Okay, so you need two registers. Okay, so this is register 1 and this is register 2. Okay, examples here. Okay, write a program to load the port B register with a value 55 and complemented port B 700 times. Okay, so now, okay, you have the value 55. Okay, you're going to send it to port B. And then after that, you're going to complement this value here, so that, okay, and send it to your port B 700 times. Okay, which is first value is 55. The second value is AA, then followed by 55 AA. How many times? 700 times. So how to do that? So because this 700 times is greater than 255, okay, so you need to have 2 registers lah. Okay. Okay, so 700 greater than 255, so you need to have 2 counter registers. Okay, one counter registers will have 10 and the second one is 70. Okay, 10 multiplied by 70, okay, total is 700. Okay, again, because you're going to use the port B to send out the value, the result. Okay, so why not? We need to, okay, the first thing what you're going to do here is you need to initialize, or sorry, you need to include this m32def.inc file. Okay, so include m32def.inc file. Okay, so after you include this file here, okay, make sure like every time you going to write down the assembly language, you include this file. Okay, because this file sometimes okay can give you marks, okay, for this one. Okay, now you're going to send 55 to your port B. Okay, before you send the 55, this value here to port B, what you're going to do to your port B? Okay, you need to initialize that. So your port B, so that your port B become an input port or output port. Okay, before we going to use the ports, any ports, we need to initialize them first. Either it is an input or output. So in this case here, we need to initialize it as a output port. Why output port? Because you're going to send this value to your port B. So every time you're going to send the value to port B, so the port B, the port become an output port. So how to initialize port B as output? By writing 1 to your DDRB. Okay, put 1 to your DDRB. Okay, so after you include this file, so why not we initialize our port B so that it become output port? And then out DDRB R70. Okay, next. Okay, next we are going to send this value here. Okay, 55 to port B. Okay, this is the first step lah. Okay, okay, so load I R16 OX55 and send it to your port B. Okay, next, okay, we are going to load the counter register. Okay, you have 2 counter register. One, we call it as a inner counter register, and the second one we call it as an outer counter register. Okay, so let's this one will become your inner. Okay, so this is I put it in R20, and this is put it in R21. So LDI R20. Okay, and then what is the value? 10, and then LDI R21, okay, with 70. Okay, so this is counter register. Okay, and then after that, I'm going to complement. Okay, so complement this value. Okay, so that the next value that will send out to port B is AA. Okay, why I say AA? Because if you complement 55, which is 010101, okay, you do the inverting and it will come 101010, which is this is 1010 is actually an AA. Okay, so to complement that, okay, why not we just use the COM, the first what you call it? Okay, we just inverting by using the first complement. Okay, first complement. Okay, so complement R16. Okay, so complement your R16, and then out port B R R16. Okay, so after we complement R16, so what you're going to do next? Then you're going to send out the value of R16 to your port B. And then after that, what we're going to do? Okay, we need to decrement the inner loop. Okay, so because this is your loop will look looking like this lah. Okay, to create a 700. Okay, we will have the inner loop and outer loop. Okay, the inner loop we have a 70 and the outer loop is 10. Okay, so 70 multiplied by 10, you will get a total of 700 times. Okay, so what you're going to do here, you're going to decrement the inside. Okay, the inner loop. Okay, so decrement R21. Okay, because this is the inner loop. Okay, once you decrement R21, so next what you're going to do? Okay, branch not equal and ulang. Okay, so where I'm going to put my ulang? So I'm going to put here, somewhere around here. Okay, I just erase this one here. Okay, and then put the ulang here. Okay, so this is a loop 1 lah. Okay, or simply I just put the loop 1 or loop 2 lah. Okay, so it's easy for you to refer to. So this is a loop 1. Okay, so where is my loop 1? So this is loop 1. Okay, so this is my loop 1. My inner loop is a loop 1 and the outer one is a loop 2. Okay, and then it will keep repeating until, okay, and then it reach 17. When it reach 17, what happened? Then I need to decrement my outer loop. Okay, so decrement R20 and then branch not equal to 2. Okay, where I going to put my loop 2? So I need to put here lah. So why I need to put here? Because I need to load back the 70 so that it will generate the second time the second time of these 70 loops. Okay, and then this loop here 70 will be executed how many times? 10 times. Okay, and then last but not least is tamat lah. Okay, which is I end my program. Okay, so tamat equal to jam tamat. Okay, so this is the program by using the nested loop. Okay, so this is the inner loop. Okay, and then this is the, sorry. Okay, so this is an inner loop and this is the outer loop. Okay, any question up until here? Okay, if no question, then okay, so this is the explanation lah. Okay, what happened for this program here? Okay, you can read it by your own. Okay, if no question, then we go to exercise. Okay, we have a few exercises down here. Okay, we can check one by one. Okay, so first, write a program that if R20 is equal to R21, then R22 is cleared. Okay, so you're going to check whether R20 is equal to R21. If yes, then you clear your R22. So how to do that? Okay, so you draw the, what we call here, the flow chart. Okay, so this is the flow chart and this is the condition. Okay, so in this case here, okay, you have two solutions. Okay, one by using the BRNE. Sorry, this is not BRNE. So this is a BREQ. Okay, because it is equal, yes, then clear R20. If you use the BRNE, then this is the what happened. Okay, so how to write the program? Okay, you choose either one. Okay, so let's choose the BRNE. So first compare R20 with R21. So R20, R21, and then BRNE. Okay, then it will go tamat. Okay, by using the BRNE, it's not equal, then you go to N. Okay, and then you put the tamat down here. Okay, and then jump tamat. Okay, what happens if the value is equal? Then you need to clear your R22. And after that, it will go to tamat as well. Okay, so this is by using the BR and E. Okay, what happens if you use the BREQ? Okay, so you write down CPR20 R21 and then use the BREQ. Okay, when this BREQ, so what happens? You know that these two numbers are equal. So you just put the same. Okay, where I'm going to put my same? Here. I put my same here. Okay, what happens? When it is equal, then clear R22, and then after that, it will go to tamat. Okay, jump, tamat. So this is my tamat. Okay, what happens if no? If the condition is false, then it will automatically go to your tamat. Okay, so this is one, jump, tamat. Okay, next. Okay, you are going to write a program that if R20 is less than R21. Okay, when R20 less than R21, what happens? R22 is increases. Okay, so this one here, please change this one here. Okay, you're going to check whether R20 less than R21. Okay, if yes, you increment your R20. If no, then you exit from. Okay, you go to N. Okay, or no operation. Okay, so here again, okay, because this one here, okay, you can choose two instructions. One is BRSH and the other one is BRLO. Okay, so BRS is this one lah. Okay, because R20 is bigger than R21, then you go here and your program. If BRLO, which if R20 is less than R21, then you increment your R22. Okay, so I just choose this one here. So what you're going to do is first compare R20 with R21. And then using the BRLO. Okay, so this one is small. I just put the small. Okay, and then small is somewhere around here. Okay, what happened when small? Okay, increment R22. So I and C R22. And then after that, okay, so jump tamat. Okay. And what happens if the condition is false? So next, we just simply put the jump. Okay, so it automatically go to here. Okay, if you use the BRSH, okay, then this is the solution. Okay, this one I think you can do it by your own. Okay, and then what about this one? Okay, this one also we already did, okay, in the previous slide, which is okay, this is similar to what we done previously. Okay, yang mana ya? Okay, this one. Okay, this one we add with 3, but now you're going to add between 2 registers, so it's similar to that one. Okay, now I'm going to show you this part here. Okay, this exercise. Okay, you are going to write program that calculate the result of 9 plus 8 plus 7 plus 6 plus 4 5 plus dot until 1. So how to do that? What are you going to do? Who will have the idea how to perform this program here? Okay, to calculate these numbers and then put the result to your register. Okay, how to do that? Okay, so this is the operation 9 plus 8 plus 7 plus
Increment, doctor.
Okay, we can use the increment and then you need to use
Increment
the
or decrement?
okay, and then other than that,
We use a branch.
okay, we can use the branch. Okay, we can do the loops.
Yes.
Okay, so in this case here, okay, so for this one here, okay, so this is the first number. Okay, we identify what is the first number and what is the last number. Okay, so this is your first number. Okay, what are the difference between the first number and second numbers? Okay, so this is the difference equal to 1. Okay, the first number and second number, the difference is 1. And the second and with the third number is also 1. Okay, and then after that, okay, after that, you're going to do the, okay, you're going to use the ADD instruction. Okay, so for the ADD instruction, you need to add between two registers. Okay, so now what we're going to do here is, okay, first we need to have the register that will hold the result. Okay, so this is the register that will hold the result of this addition here. And then this is the register Rn, which is this register here will always decremented, okay, because we're going to add with 9 and then 9 with 8. Okay, it will become 8 and then after that it will become 7 until it become 1. So this is your Rn. Okay, so first, what you're going to do is, okay, you need to have 3 registers here. Okay, so first is your CLR R20. Okay, so this is your result. Okay, so I just clear my result register so that my result register will have initial value of 0. Okay, and then after that, okay, LDI R21 with 9. So I'm going to make sure that, okay, this R21 become my first number. Okay, and then the other register is my counter registers lah. So LDI R16 with 9. So this is my counter register. Okay, why 9? Because 1, okay, if you add this number here, you know that the total of counter looping that you're going to have is 9 loops. Okay, 9 times. Okay, so from 1 to 9. Okay, next, what I'm going to do is, okay, we do the addition. Okay, do the ADD. Okay, ADD R20, okay, which is my result, 0, plus with our first number. Okay, so this is the first number, R21. Okay, so now what happened here is R20 equal to 0 plus with 9. So this become my first number. Okay, then decrement R21. So now what happened? R21 will become 8. And at the same time, okay, I decrease my counter register. Okay, so decrement R16. So R16 also become 8. And after that, okay, do the BRNE, and this one here go to ulang. So we are going to put my ulang. So here is my ulang. And what happened? And it will add. Okay, so now R20 is 9 plus with R21. R21 currently is 8. Okay, now it becomes 17. Okay, and then decrement R21, which is this becomes 7, and this also becomes 7. And since the counter is not yet 0, and it will keep repeating. Okay, so now this one is 17 plus with 7, and then it becomes 24. And this will keep repeating until your counter registered equal to 0. Okay, what happens when 0? Then end my program. Okay, so tamat, jump, tamat. Okay, so this is how you're going to, this is the program that you're going to write in order to perform this equation here. Okay, so any question up until here? Any question for these examples? If no question, then we go to the next examples. Okay, so in here, okay, you're going to write a program that calculates the result of, okay, now you're going to calculate 1 plus 3 plus 5 plus ... plus 27. Okay, so in this case here, okay, so first, as I mentioned earlier, okay, so you need to have the register that hold your first number. So this is your register for the first number. And then find out what are the difference between the first number, second number, and third number. So the difference is 2. And what would be your last number? So this one here is what we call here. Okay, so this is my last number. So this last number is actually my counter register. Okay, because okay, you can count, you can identify how many counter register that you want, but I think it is not practical to do that. Okay, because you need to find, okay, first 1, 3, and then you count until 27. How many counter register that you're going to put? Okay, instead of we count the total number of counter register, why not we just compare with this number here? Is it less or greater? Okay, and then it will keep looping, do the loops. Okay, so now we're going to write the program. Okay, so first, okay, so this is the first number. So this first number here, you're going to put it to your register, and then the different also, you need to put it to your register as well. And this last number become your, the one that you're going to compare in order to do looping. Okay, so in this case, okay, I just LDI R21 with 1. And then, okay, so before that, okay, because this is an addition, okay, so we need to use the ADD instruction lah. So ADD must be between 2 registers. Okay, RD and RN. Okay, so the RD is your result, while RN is the numbers, okay, that is starting from 1, and then it becomes 3, and then it increase to 5, 7 until 27. Okay, so again, I need to clear my results here, result register. So CLRR20. Okay, so this is my first number, and this is my result. Okay, next. Okay, we just simply add. Okay, ADD R20 with R21. Okay, because 0, okay, we're going to add this first number here, 0 plus with 1, you get 1. Okay, so now what happened here is R20 sama dengan R20. R20. Okay. 0 plus with 1. Okay, and then the result will be 1. And then after that, okay, so now I'm going to change the R21 so that the next number R21 is 3. Okay, so how to do that? By increment. How many? 2 times. Okay, you're going to increment R21. So the next number that you're going to add here no longer 1, which is 3. So you increment R21. So what happened to R21? So R21 now become 3. Okay, and then after I increment the R21, okay, so what I'm going to do? I'm going to compare. Okay, compare with what? With this number, or you can compare with okay, you can. So this is your R21. Is it your R21 less than 28, for example, or less than 28, which is it will include the 27 lah. If you put the 27, then what happen? This number here will not be add in your program. So that's why I need to compare with 28, not 27, because the 27 I need to include in my calculation as well. So CPI R21 with 28. Okay, is it my R21 is less than 28? Okay, if yes, no. Okay, so this one here, I can use the BRLO. And this one, I can use the BRSH. Okay, so what happened when smaller? So BRLO, when it is smaller, then what happened? We're going to do the addition. Okay, so ulang. Where I'm going to put my ulang? Here. Okay, then what happened? So now it will add again. Okay, so R20, which is, okay, the current value of R20 is 1. Okay, and then plus with 3. Okay, and then you will get 4. Increment R21, increment R21. Now it becomes 5. Compare with 28, since 5 is smaller than 28, and it will keep repeating. Okay, so now this one here is 4 plus with 5, and then it becomes 9. Increment this is become 7, and it will keep increase until the last number here, which is 27. Okay, when 27, okay, and then it will looping, and when this one here, okay, the result you already add with 27. Okay, so the result you add with 27, and then you got the results here, and then it increment R21, R21, so now it becomes 29. So since R21 is 29 greater than 28, then it will exit of this loop. Okay, so what happens when exit? So you can put the jam tamat. Okay, so this is the solution, how to perform this equation here. Okay, any question? Okay, so we have another exercise. Okay, we have about 10 minutes. Okay, so this is another exercise. Okay, so this is taken from, my name exact is not mistaken. Okay, you are given a refer to the figure Q3 below. Okay, you're going to write the code, the assembly language that will read 10 bytes of data at one time. Okay, the data are located at memory address 200 until 209. Okay, and then once the data is read, the individual data is filtered. If the data is equal or greater than 0, okay, then it will be stored in a memory address starting at address 300. Okay, whereas if it is less than 0, okay, then the data will be stored at memory address starting at address 400. Okay, so this one with 300 here. Okay, so example data are given below. So this is your data. Okay, the data is located at this memory address, and then you're going to compare this data here with a 0. If the data is smaller than 0, so what happened? Okay, okay, if the data is greater than 0, greater than 0, okay, then it will store to memory address at 300, and smaller than 0, it will store at memory address at 400. Okay, so I think we need to change this question here, because by looking at these figures, okay, the one that with a smaller number will be stored at address 300. The one that with great number, okay, bigger than 0 will be stored at address 400. So we'll just simply change this one. Okay, so this is a 400 and this is 300. Okay, so how to do this one? Anyone? What are you going to do?
First
Oh,
thing,
Okay, first thing, what are you going to do?
we load the data in register by
Mhm.
using LDS instruction,
Okay,
and then we compare
okay. You compare with
with
0.
yes, and
Uh-huh.
after that we initial the org 300 or org 400.
Okay. So now, before you try to answer this question, okay, so I advise you to draw the flow chart, okay, so that you can see what are the information, okay, that you can extract from this problem here. Okay, so this is the flow chart. Okay, this is your start. Okay, then what you're going to do after you start is you're going to read the data. Okay, which is it from address 200 until 209. Okay, so this one here we can use the condition lah. Okay, which is you can do the counter. Okay, and then after you read the data, so what you're going to do? Okay, you're going to compare that data with 0. Okay, so this is another condition. Okay, so is it greater than 0? If yes, sorry. Okay, so if yes, what happened? If no, what happened? Okay, so if yes, and this is no. Okay, so if yes, what happened? Okay, you're going to store at address 400. Okay, starting at 400. If no, you need to store at address 300 plus. Okay, and then what you're going to do? Okay, you check back whether you already read all this data here. Okay, and then this is similar lah. Okay, so check back whether you read all the data, and when you already finish read the data and do the sorting, okay, so what you're going to do is then it will go to N. Okay, so the question here is Okay, for this one here, so how many counter register in order to read the data? Okay, so you have a total of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you need 10 counter register. Okay, so your register counter, is it counter smaller than 10? Okay, if yes, then load the data and compare. If no, then it will go end. Okay, so this one you can use the BRENE and BREQ instruction. Okay, what about this one here? Okay, you're going to compare the number that you read earlier, okay, from this address with 0. What is the branch instruction that you're going to use? Is it BRLT or BRGE? Is it BRSH or BRLO? Or is it other than these four here? Which instruction that you're going to choose?
RLO.
Yes, wait. Instruction set. Okay, and then here. Why not we just use this one? Okay, branch if minus, branch if plus. Okay, because now you're going to compare. Okay, your number, is it a minus or plus number? Okay, by looking at the, okay, you see here. Okay, all the what we call here, all the numbers here. Okay, if you see, this is a signed number. Okay, why I saying that this is the signed number? You see all of the value here, all of the signed value here is 1, while this one here, the signed value is 0. So why not we use the BRPL or BRMI? So this is a BRPL for plus number, and this is a BRMI for negative number. Okay, because this one, if you change it to binary, for example, FE you change to binary is 1111 and 1110. Okay, you see, sign number is 1. 80 change to binary. Okay, and then 99. Okay, change it to binary. You see, the sign number all indicate it is 1. Okay, AA, change it to binary. Okay, so you know that, okay, from this similarity, you know that, okay, this is a negative number. What about this one? Okay, 17. 17 is 0001, and then 7 is 0111 lah. Okay, you see? 12, 0001 for 1. 40, 0100. 00, of course lah, 000. 21, 0010. See the similarity? All the sign is showing that it's a positive number. Okay, so why don't we use the BRPL and BRMI? Okay, BRMI for the negative number, minus number, and BRPL for positive number. Okay, so now what we're going to do here is, okay, so we're going to write down the program, okay, according to this flowchart here. Okay, so we just include the files dot include m32 dev .inc. Okay, you include the file, and then, okay, we're going to have what we call here 3-pointer register. Why I saying that 3-pointer register? Because you have 3 addresses here. Okay, one at address 200, and then the second one is address 300, and the third one is address 400. Okay, so why not we just use the pointer register in order to point to this location here. Okay, so I just assume that this one is become my X pointer register, D is my Y pointer register, and D is my Z pointer register. Okay, because I'm going to load the data, okay, from this address and then increment the pointer register by 1, so that the next data that I can load is 201, 202, 203 until 209. Okay, this is also similar, which is the first address that I'm going to store is 300, then I increment my Y, so that is pointed 300 through 303 and until 305. And this one also, I started my pointer register Z to point at address 400, and then it will keep increment until the last address here. Okay, so now what I'm going to do here is I'm going to initialize so that my pointer register is pointed to this address. So LDI, okay, R27, 0x02, and LDI R26, 0x00. So what happened here? X now point to address 200. LDI R26, 29, OX03, and this one 00, and this is Y now point to address 300, and last but not least is LDI R31, OX04, and this one LDI R30, OX00. Now my Z pointer register pointed to address 400. Okay, so initialize your pointer register. Okay, once you initialize your pointer register, next, what you're going to do? Okay, we're going to initialize our counter register so that the counter register equal to 0. So LDI R16 with 10. Okay, so this is my counter. Okay, and then I'm going to read the data. Okay, load the data and put it to a register. Okay, so LDI, sorry, not LDI, LD. Okay, we're going to use the LD. Okay, because we use the pointer register. Okay, so LD by using the indirect addressing mode, R17X plus. Okay, means that I go to address pointed by X, which is 200. Okay, so go to address 200. So this is address 200. Take the value FE and put it to my R17. And then at the same time, my pointer register X increment by 1. So make it smaller so that we can see it very clearly. So what happened? Okay, so now what happened here is R17 will have value from 200, which is FE. And then X now point to new address 201. Okay, and then after that, what I'm going to do? Okay, when I read the data, next I'm going to compare with 0. So what instruction that you're going to do to compare with 0? Okay, just simply use the CPI instruction. Okay, so CPI, what value that I'm going to compare? The value from R17, the one that I load from address 200. Okay, so R17 with what number? Compare with 0. Okay, then I'm going to choose either you're going to use the BRMI or BRP. VRPL. So in this case, I use the VRPL. So VRPL. What happened when VRPL? So it's saying that it's a positive number. Okay, so this is a positive. I just put down there. So what happened when positive? So when positive, I need to store the data, okay, to address location starting from address 400. Okay, so ST Y plus R70. Okay, and then decrement R60. Okay, once I what we call here, I finish load the data, I need to decrement my counter. Okay, so that the counter now become 9. Okay, and then branch not equal ulang. Okay, so where am I going to put the ulang? Okay, so ulang must be put here lah. Okay, because we need to read the data again. Okay, so ulang I need to put somewhere around here. So this is my ulang. Okay, so I load again R70 with the value from 201. Okay, which is what is the value from 201? Okay, 17, yeah. So 17. And then my X now pointed to 200. 2. And then compare with 0. Okay, before that, okay, this is when the true when we use the BRPL and the condition is true lah. What happens when the condition is not true? Okay, that is a negative number. Okay, when the negative number, so need to store at this address. Okay, so store dekat. Okay, STZ plus R17. Okay, and then jump JMP decrease count. Okay, so I'm going to decrease my counter. Okay, after I store to this location, then I need to decrease my count. Where is my decrease count? So this is my decrease count. And it will decrease the counter, which is decrease R16, and branch not equal ulang. And this will keep repeating until 10 times, which is all the data already been loaded to R17, and then it will compare whether it's a positive number or negative number, and store it to the to this memory address, to the specific memory address respectively according to the instruction. Okay, and then once I already check all the data here, so what I'm going to do is it will exit from this loop. Okay, then I just put jump here and here. Okay, so it will keep repeating here after it finish all the sorting of the positive and negative number. Okay, so any question up until here for this exercise? Any question? Okay, as I mentioned, for this kind of question, you need to draw the flowchart. Okay, so that you know that what you're going to do and identify what is the best instruction that you're going to use. Okay, if no question, okay, actually we have another exercise here. Okay, so for this one here, maybe I will ask you to do it as your assignment. Okay, so this is become yours. This is your second or third assignment, is it?
Yeah, third, I think.
Okay,
No,
so this become your third assignment.
You didn't give us second assignment.
Or you can simply combine it with the second assignment, because the second assignment you not submit yet, correct?
That I don't think we had any second assignment.
You didn't give us a second assignment.
Oh, I didn't give you the second assignment. Okay, so this become your second assignment. The first one you already submitted, is it?
Yes.
Okay, so this is your second assignment.
Okay.
Okay, so thank you, class.
Thank you.
Okay, why my screen is blank?
Doctor,
Okay.
can we have